Hello everyone, welcome to our next video, and today we are going to continue with exercise 6.3 of chapter 6, that is triangles. So we had completed up to question number 3, today we will move on to question number 4. So let's see what it asks. This is the diagram given and these are the given instructions and what we have to prove. So let's look into that. The triangle is TQR and we have two lines joining different parts of the triangle. So in this diagram it is mentioned that QR by QS is equal to QT by PR. That is QR by QS is equal to QT by PR. That is what is given. We have to prove that PQS and TQR are similar. That is PQS and TQR are similar. This smaller triangle and the larger one are similar. That's what we have to prove. Now let's look at something interesting. Since 1 and 2 are equal, okay, if I take triangle PQR, this one PQR, in this triangle 1 and 2 are equal, that means triangle PQR is isosceles and equal sides, if the angles are equal then the opposite sides will also be equal, that is PQ and PR must be equal. So let's write that. So in triangle PQR, angle 1 is equal to angle 2, therefore 1 and 2 are equal, that is PR and PQ must be, therefore PR will be equal to PQ, opposite sides of equal angles. Okay, so therefore these two are equal. How does it help us? We will see this. Okay, this is number 1. How it helps us we will see in the next page. PR and PQ are equal. PR and PQ are equal. Now let us move on to these two triangles because we have to prove they are similar. So from triangle PQS and triangle TQR. Okay, let's do one thing. Before going into this, let us see what is given. Now, we know QR by QS is equal to QT by PR. So if this is equal and we know that PR is equal to PQ. So in place of PR I can write PQ. So it will be QR by QS is equal to QT by PQ. This is from number 1. Okay. So we have this one. Now we will move on to these two triangles. So from triangle PQS and triangle PQR, what do we have? If we have to prove these two triangles as similar, we have three different criteria: angle, 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 side, 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 or side angle, side. So let's see what we can do. We have PQR, the smaller one, and TQR, the larger one. Okay, PQS and TQR, this one. So PQS and TQR, look at this. QR by QS is equal to QT by PQ. These are the corresponding sides of this triangle, these two triangles. Okay, see, QR is the side of PQR by QS, which is QS in PQS. Then we have QT, which is of triangle PQR, and we have PQ, which is of this triangle. So two corresponding sides are in proportion. So from 1 we can write QR by QS is equal to QT by PQ. QT by PQ. This one is from number 1. Okay, this one we will write number 2. So this will be from number 2. Okay, so from number 2 we have got these two as equal. Again, PQS and TQR. In these two triangles, angle Q is the common angle. So we can write angle Q is the common angle. Therefore, triangle PQS will be similar to triangle TQR by side angle side postulate. Hence we have showed the required criteria. Okay, I hope that's clear. Very simple sum. Diagram may seem complicated, but it is not at all complicated. Look at the conditions. and we can solve easily. Hope it is clear. Let's move on to the next one. This is question number 5 and it is a very simple sum. Let's look into it how to do. This is given angle P and angle RTS are equal. So these two angles are equal and we have to prove RPQ and RTS are similar. That is RPQ, this triangle, and RTS, this smaller triangle, these two triangles are similar. Very simple sum. How to do? Let's take these two triangles. So proof from triangle RPQ and triangle RTS. What we have, this one is given, angle P and RTS are equal. This big triangle here, angle P, and in the small triangle, angle T. So these two angles are equal, it is given in the question. So we have angle P equal to angle RTS, which is given. Also, if you look carefully, in this small triangle and in this big triangle, this angle is the common angle. So we can write angle R is the common angle. Therefore, triangle RPQ will be similar to triangle RTS by angle postulate. Very simple, as I said, hence showed. Okay, just two angles. One is already given and one is the common angle. And that's how we prove by angle postulate. Let's move on to the next one. So we move on to question number 6 and let's see what it asks. This is the diagram and here it is given that ABE and ACD are congruent triangles. So ABE, this one, and ACD, ABE and ACD, this triangle and this triangle are congruent. This means their corresponding sides must be equal, not in proportion but equal, because they are congruent. And we have to prove that ADE, that is this small triangle, ADE is similar to ABC, ABC. Let's see how to solve, which postulate we can use. So since triangle ABE is congruent to triangle ACD, therefore their corresponding sides must be equal. So what are the corresponding sides? AB must be equal to AC, and AB and AC must be equal, and AD and AE must be equal. So we can write therefore AB equal to AC and AE equal to AD. Okay, this one is number 1, this one is number 2, and we can write this corresponding by CPCT. CPCT means corresponding parts of congruent triangles. Okay, corresponding parts of congruent triangles are equal. So we have, since these two are congruent, AB and AC will be equal, AD and AE will be equal. Okay, now if I divide 1 by 2, 1 divided by 2, what does it give us? AB by AE is equal to AC by AD. Okay, AB by AE equal to AC by AD. AB by AE is equal to AC by AD. This can be written as AB by AC, side change, is equal to AE by AD. It is AB by AC equal to AE by AD. That means these are the corresponding sides. Look carefully. AB by AC is the bigger triangle and AE by AD is for the smaller triangle. The two triangles we are trying to show similar, and we can see that the corresponding sides are in proportion. AB by AC equal to AE by AD. So this we can take as number 3. Okay, let's move on. Let's take these two triangles now. From triangle ADE and triangle ABC, the two triangles we have to show which are similar. Okay, so from here we can write AB by AC is equal to AE by AD. This is from number 3. And the second part is ADE and ABC, angle A is the common angle in both cases. Angle A is the common angle. Therefore, triangle ADE will be similar to triangle ABC by side angle side. Side angles are two sides and one angle. The angle between the two sides, which is the required criteria. So that's how we solve question number 6. Again, a very simple one. Congruency proves that these two sides are equal. One extra thing we have to do, just that we have to divide 1 by 2 to get the proportionality of sides. And that's how we solve question number 6. I hope it is clear, because these sums are not tough, they are very easy. And almost all the sums in this exercise are somewhat related to one another. So if you can do one, you can understand how to do the other. Okay, so let's move on to the next one. Moving on to question number 8, I left question number 7 because I want you to do question number 7. Very easy sum. There are 4 parts of question number 7. You can do it easily. I'll give you one hint. All of the 4 sums will be proved by angle-angle postulate. 2 angles you have to show they are equal, and you can do it because we have already done number 5, 6 and 4, 5 and 6, I guess. Yeah, 4, 5 and 6 we have done. So you can do question number 7 easily. Moving on to question number 8. So it is given that ABCD is a parallelogram, and we have to prove that ABE, this big ABE and CFB are similar. Okay, this big one and this corner one, these two are similar. Okay, so since this whole thing ABCD is a parallelogram, opposite angles will be equal. That means angle A and angle C will be equal. Okay, again, since these are parallelogram and AD is produced to E, so it is extended part of AD. That means AE and BC will also be parallel. These will be parallel sides. So if these two are parallel and this is the transversal, then we must have this and this as equal, these two angles, because they are alternate angles. Okay, parallel sides, transversal, this will be equal to this as. Okay, I guess now it is clear. Okay, these two will be equal because they are alternate angles. So as a result, what happened? From this big triangle and this small triangle, these two are equal and these two are equal. So by angle-angle postulate, they are similar. So let's show it. So this is the proof. Since ABCD is a parallelogram, therefore angle A will be equal to angle C, since they are opposite angles. Number 1. Also, AE is parallel to BC. AE is parallel to BC and BE is the transversal. Okay, BE is the transversal. Therefore, angle AEB will be equal to angle FBC. These are alternate angles. Okay, clear? So this is number 2. So now let's take these two triangles. From triangle ABE and triangle CFB, what do we have? We have angle A equal to angle C, and this one, angle AEB is equal to angle FBC. So since two angles are equal, therefore triangle ABE is similar to triangle CFB by angle-angle postulate. Show. Very simple again. So as I said, the questions in this chapter are very simple, and whatever we have done till now will be sufficient for you to solve up to question number 10. If you have any problem, then do ask me in the comment section that if you have faced any problem in question number 7, 9 or 10. So whatever we have done till now, use it, understand it, and use it to solve question number 7, 9 and 10. If you face any problem regarding these sums which I have solved or the sums I have asked you to solve, do ask me in the comment section and I will be there to help you out. If possible, I will be sharing any solved answer so that you can understand. So thank you everyone, and until next time.